Hello friends, very good morning to all of you. So today we are going to discuss PF54 part 2, that is CSRf attack against the client. So in this session we'll just talk about this common client vulnerabilities, right? What vulnerabilities we have and maybe how we can protect. So in this whole session you can see we are going to talk in all those parts. So let's begin. So in this section we'll discuss on the CSRf attack against the client. So let's jump to the slide. Yeah, so what is cross-site request forgery then, and why should we pay attention to it? So CSRf is one of the most common attacks on the internet, and it is also listed in the OSP top 10, a list of top uh, like the current top 10 most dangerous web application security flaws and yeah, effective method for dealing with them. So if you can just go to the WASP top 10, you can see this CSRf is one of the attack. So how this attack is happening and how we can avoid it. So let's try to understand that part. So in a CSRf attack targeting an OAuth flow, the attacker does not directly obtain the authorization code from the server, like from the authorization server. Instead, they exploit the user session to trick the server into providing the code. And let's see how this can happen. That means like attacker is not directly getting the code, authorization code from the authorization server. Instead of that, they are trying to trick the user session. That means already user have some session in the browser. So the attacker will try to exploit that and then try to get the code from the authorization server to their own attacker site. So how that can be happen? So let's see. So user logs in. So the user log into the application that uses OAuth to connect to a service. Now the application will redirect the user to the authorization server, let's say ping federate, to request access. The user grants permission and the server prepare to send back an authorization code. That the authorization server will prepare to send back an authorization code. Now the part will come malicious website. Now the user is tricked into visiting a malicious website while still logged into the original application and the authorization server. That means user have already a valid session in the browser, and using some trick or by mistake user can click on some link that is something a malicious website. Now what this malicious website will do, this malicious website then can automatically send a request to the authorization server using the user's browser. That means user or browser already have a session, so from the same browser a new request will go to the authorization server, and this request will craft it to look legitimate, and because the user is already logged in. So in that case what happen, authorization server will process that request. That means already user first time try to log into the application redirected a user to the authorization server issued a code to the user, and then user is have the valid session in the application as well as like in the browser, a valid session like in the browser for that authorization server also. So now the user by mistake clicked the malicious website link, and then that malicious website crafted a new request and sent back to the ping federate authorization server. Now this request looks to be legitimate. That's why ping federate is issuing a authorization code to that malicious website. That means your authorization code is now hijacked or capped or attacked or basically stolen, I'll say, compromised, anything, yeah, you can say. Now by getting authorization code, what that attacker can do, we can discuss other section in other section, but yeah, at least your code is compromised in this case. The authorization code is went to the malicious website or to the attacker site. Yeah, and why this works, there are two things, right? Browser trust and lack of protection, right? The authorization server here trust request coming from the user browser because the user is already authenticated. That's why here browser trust is there. Another thing is the lack of protection. Yeah, so if the app does not implemented CSRF protection like checking a state parameter or using anti-CSRF token, it can be tricked into thinking the request is valid. That's why you see that when a client is sending in the auth code flow, when the client is sending, maybe you remember that the workflow diagram I just shown you for the auth code flow. So in that, the client is sending authorization, just redirecting a user to the authorization server while sending some request, some information. And what are those information? It's like the scope, client ID, redirect URI, and the state parameter. and in the state it's just having the opaque number kind of thing, like say random number something. And this state parameter is only helping to avoid the CSRf, because it's a kind of validation happening, right? Because the client will send that state parameter to the ping fetted authorization server, and then authorization server will send the same state parameter back to the client just for the validation part. So in this way, the CSRf attack you can avoid. It is not possible by just passing a simple state parameter. You can avoid the CSRf attack. So the mitigation for an Oauth client here is to just, as I mentioned, is to generate an unguessable state parameter and pass it along to the first call to the authorization server. The authorization server is required by the specification to return this value as is as one of the parameters to the redirect URI. Then when the redirect URI is called, the client checks the value of the state parameter, right? So that's the help of state parameter. So the client first send that to in the request to the ping federate authorization server. That server done that authentication part of the user and then generated authorization code and send back to the callback address or the redirect URI of the application. Now here again the application, or you can say client, will do the validation, check the value of the state parameter. What is that? Is it matching what I said, or it's something different? If it is different, it will stop that. So if it is absent or if it doesn't match the value originally passed, the client can terminate the flow with an error. This prevents an attacker from using their own authorization code and injecting it to unsuspecting victim's client. So by just implementing this small thing, you are avoiding that. So those all things we just need to understand one by one, like what are all the practical implementation we need to make to avoid these kind of vulnerabilities. Nowadays you can see there are many tools came in the market. It's not one tool, there are many, and industry also people are using those tools. What those tools are doing, like those tools are helping you to just scan the vulnerability. Let's say you build some solution but you don't know what are the vulnerabilities or from where the vulnerabilities can come. So now you're dependent on those solutions or those tools. Those tools are helping you to give the result, hey, these are the vulnerabilities and fix in this ways, like that. But at least you need to have an idea. Maybe that tool can do some mistake, right? But if you have the proper idea on all those vulnerabilities, you can take a help from those tools, that is fine. But you at least understand what those vulnerabilities the tool is telling you, and what are the solution and how I can fix those vulnerabilities. And if any other thing also, you can just look into those. Yep. So that's why these vulnerabilities are very, very important to understand. And if you can just, this is for the learning purpose also. And in the interview, you can see people can ask you these type of questions. When you're giving for an interview for this IM role, people can expect you to understand all those, and they can put some questions also on this. So you need to explain like this. Okay, so this is the end of this section. Let's jump to the next. If you have any questions, please put in the comment section so we'll discuss again. Thank you.